Students, welcome to the new session. In this session, we are going to discuss about Introduction to Asymmetric Key Encryption. This is the third important chapter in cryptography and network security. Whereas the first chapter is totally about the introduction and knowing classifications of cryptography, knowing some mathematics of cryptography and all. The second part of this course is about symmetric key encryption, which we have seen in the previous classes. Now we are moving to the third important chapter that is called as asymmetric key encryption. Before moving to the exact topic, let us know the outline first. So whenever we are going to the new topic, so why we are moving to this new topic is the thing. So when we have a disadvantage or limitations to the existing system only, we will be planning for the new topic, right? So is similarly, we are moving to asymmetric key encryption as we have some limitations to symmetric key encryption. So we are going to highlight these two first. Then knowing about asymmetric key weaknesses and along with the solution. And as asymmetric key is a combination of two keys. So there we have to have one point that how to share the key between two entities, how to manage with the keys and all, right? So for that, we need asymmetric key agreement between the two users of one session, right? So the key agreement can be possible with one of the algorithm, very important algorithm, that is Diffie-Hellman key exchange algorithm. Whereas this algorithm, we are going to talk about this algorithm in the upcoming sessions. So let us move to the first thing, that is the limitations. Coming to the limitations part. Here the limitations are very less to symmetric cryptography, but we have to know what are those and how to come out of it, right? So the first point to be known is as the key transmission of the, as we know, symmetric key, we will be utilizing the same key between the sender and the receiver, right? So it's both the sender and receiver will be utilizing the same key, right? So this same key, whatever the same key we have, that is to be shared between two number of entities. Now, when we are sharing this same key, there is a chance of eavesdropping the key also along with the ciphertext. So when an intruder adversary is having ciphertext and also the key in his hand, then everything is done, everything collapsed, because ciphertext can be decrypted with the same key and he can have whole plain text with him. So this is the main disadvantage, where the same key has to be transmitted between the sender and receiver for sure, because we are going to encrypt that at the sender side, and at the receiver side only that key should be there to decrypt it. Right. So this is one of the main concept where we are lagging in the symmetric encryption, only in the point of secret key transmission. Other than this, symmetric key encryption is a perfect thing, right? Now, when we have this kind of a limitation, then how we are overcoming that? So to overcome that, we are moving to the concept of public key encryption. So for public key cryptography or public key encryption, asymmetric key encryption or asymmetric key cryptography, we can call in four ways, right? So this is invented to come out of the problem which we are facing in the symmetric key encryption, that is the common key sharing between two entities, right? So along with this, we can reach with key exchange problem so that we can achieve secrecy. We can go with a trust problem. So for that, we are achieving authentication. So secrecy and authentication both to be achieved in public key cryptography. That means, so we can say that the main aim of public key cryptography is to achieve secrecy and authentication, which we are missing in symmetric is a secrecy, right? When we are sharing, the key may be into the hands of attackers or as a ciphertext. So to have all this in a proper way, we are moving to the public key cryptography, where public key cryptography is invented to address two important problems of symmetric, that is the key exchange problem and the trust problem. So for that, we are going with the two services or else two important goals of asymmetric key. So to provide secrecy and the authentication. Then now asymmetric. So always we are discussing what is this first. Asymmetric cryptography is the pair of keys. So where the pair will be having one public key and one private key, one public key and one private key. So in this, if we are encoding with one public key, if our plain text is encrypted with the public key, then you will be generated with the ciphertext, right? Now this ciphertext can be decrypted with the pair of this public key, that is a private key. The public and private key must be as a pair. Okay. So this is what we should understand first. So who is generating this pair and all will be the secondary thing, which we will be discussing for sure in this upcoming sessions. Public key will be always generated by PU. Private key is called as PR. So this pair is important in public key cryptography to address two issues, that is secrecy and the authentication. Now, if I am encrypting with public key, I must have private key to decrypt it. If I am encrypting with private key, I must have public key to decrypt it. So the pair is pair to be available always to encrypt or decrypt. So this is asymmetric encryption. Public key cryptography for proving secrecy. So we are saying 2 points, right? The first point is the secrecy, the second is the authentication. To prove your secrecy, what we are doing is we are encrypting your data with the public key of the receiver, right? Public key of the receiver. Now, how? See here. There are two users. Let me say user X and user Y, right? User X and user Y. Now, user X and Y will be having their own public keys, right? Their own public keys and their own private keys. Now, if I utilize a public key of allies, a public key of allies. See, I am going with a transmission between the Bob and the allies. So where Bob is the person who will be acting as, Bob is a person who is acting as a sender here and Alice is a receiver. Now, when I am ongoing with the one transmission between these two, Bob and Alice, Bob to Alice and Alice to Bob. So I am writing this. Now, Bob must be registered to the with the authorizations and all first. Similarly, Alice also will be doing all the authorizations first with the security thing, right? Now, after doing this, both will be generated with his own public and private key. Okay, so he will be having his own public key, he will be having his own private key. Similarly, Alice also will be having his own public key and his own private key. Got this? Now, after this, what we are doing, who is giving all this public key, private keys is the secondary thing where we'll be discussing in the key distribution, like there is KDC, key distribution center. So all those will be coming in the upcoming sessions. Don't worry about it. Now, Bob, after authorizations and all, he will be having his slot with Joy's public key, Mike's public key, Ellie's public key, Ted public key. So this is a network of public keys which is available to the Bob. So whomever Bob is about to communicate, he or she will take that person's public key and he will encrypt the data. Okay, X is a plain text. So we are encrypting that with the public key of the Alice. Now, who can decrypt it? only see, as I am utilizing public key of Alice, who can decrypt it? Only private key of Alice can decrypt it. Got this? So that is the reason we should have a lot with all the public keys who are available in that network. Got this? Now, as I am doing public key of Alice, doing encryption to the plain text X. So my Y is generated now, which is a ciphertext. This ciphertext I will be sending to the network. So from there, receiver is about to receive. Now my receiver is Alice, right? So Alice will be applying his own private key to decrypt it. Okay, now how can I say I have proved with my secrecy concept? See, as I am encrypting with public key of Alice, only Alice can decrypt it, no other can do that. Got this? Only Alice can do this, no other can do it. So my content is in confidential mode for sure, and my key is not transmitted anywhere. Got this, I guess, right? Now, let us move to the next concept, that is public key for proving authentication. But authentication will be having one problem. Now, let us discuss that also. Now, first of all, public key cryptography for proving authentication. See, when I am saying authentication means who is sending the data, right? Who is sending the data? Authentication indicates that who is sending the data with whose signatures and all, and sending the data to the other person, right? So for this, what I am doing is, see, I am taking my own private key. See, I am Bob here, Alice is here, right? Now, I am taking X as a plain text, and this plain text I am encrypting with my own private key. See, Bob's private key. We have utilized Bob's private key so that who can decrypt it is a thing, right? So instead of knowing who can decrypt it, as I am utilizing private key of Bob, no other person will have this private key except Bob, right? No other person will have this private key other than Bob, so that we can prove that Bob is the right person who is sending this data. So authentication is very clear, like who is sending that. Later, Bob cannot deny that I didn't send this message to you, right? Here, the authentication is very clear because this is a private key of Bob, which will not be available to any other in the universe except Bob. Okay, but what is the disadvantage here? When I am encrypting with Bob's private key, Alice is ready to decrypt it, but he has utilized private key of Bob. So what is the pair of this public key of Bob, right? So Alice will be searching for Bob's public key here. See, Bob's public key will be available. He will take his Bob's public key and he will decrypt the data so that he will be having the ciphertext in his hand. Now, what may be the disadvantage here if I utilize with the authentication concept? See, if I am going with the private key of Bob, as public key of Bob will be available to Joy, Mike, Ted, along with Alice, right? So any of this person can, any of this user can decrypt the data because they will be having public key of Bob, right? So this is the main disadvantage which we have while we are proving with the authentication. But for that also we have solution.